Hey everyone, welcome back to another deep dive. Today we're going to be taking a look at AWS Elastic Beanstalk.
Yeah, looking forward to this one.
Me too.
Yeah.
So as mid-level cloud engineers, I think you probably have at least heard of Beanstalk. I imagine a lot of you have used it at some point.
Yeah.
But we're going to go kind of deep into this today. So maybe we can even uncover a few things that you maybe hadn't thought about before. And also, I'm hoping this will be particularly helpful if you're studying for that AWS Solutions Architect Associate exam.
Absolutely. Beanstalk is a pretty common topic that comes up, and it really helps to have a good understanding of what it does, and when you'd use it.
Yeah, for sure. So let's just start with the basics. What is Beanstalk in a nutshell?
So basically, Elastic Beanstalk is a service that makes it super easy to deploy and scale web applications and services on AWS.
Okay. And how does it actually make things easier?
Well, it handles all that messy infrastructure stuff for you behind the scenes.
Like what kind of stuff?
Things like provisioning EC2 instances, configuring load balancers, setting up auto-scaling, and managing all the other little details that go into keeping your app up and running.
So I can just focus on writing my code and not worry about all that other stuff.
Exactly. You can just upload your code and Beanstalk takes care of the rest.
Yeah.
It's like having an invisible ops team working for you.
That sounds pretty amazing.
Yeah.
Especially when you're dealing with unpredictable traffic or like sudden spikes in usage.
Yeah, absolutely. It's a lifesaver in those situations. Let's say you launch a new web app and it suddenly gets a ton of traffic. Beanstalk can automatically spin up additional servers to handle the load and then scale back down when things calm down.
So I don't have to like manually provision a bunch of servers and hope for the best.
Nope. Beanstalk handles it all automatically. You just sit back, relax, and watch your app scale effortlessly.
Okay,
Yeah.
I'm sold on that. Now, how does Beanstalk fit into the whole AWS ecosystem? Like, how does it work with other services?
It integrates really well with a lot of other core AWS services. Think of it like the conductor of an orchestra. It brings together things like EC2 for Compute S3, for storage RDS for databases, and CloudWatch for monitoring.
So it's not just about easy deployments. It's about bringing all these different pieces together to create a robust and scalable environment for my applications.
Exactly. And that's one of the things that makes Beanstalk so powerful. It's not just a standalone service. It's a platform that leverages the strengths of the entire AWS ecosystem.
Got it. Okay,
Ah.
so we've got this high-level overview of what Beanstalk is and why it's awesome. Let's dive a bit deeper now and talk about some of its key features. What are some of the things that really stand out to you?
Well, first off, it's incredibly versatile. Beanstalk supports a ton of different platforms like Java, .NET, PHP, Node.js, Python, Ruby, basically every major programming language.
So no matter what I'm building or what language I'm using, Beanstalk can handle it.
Pretty much,
Right.
yeah. And another key feature is the flexibility it offers in terms of deployment methods.
Okay, like what are my options there?
You can use Git for seamless version control. You can upload your code directly as a ZIP file, or you can even use an S3 bucket as your source.
So no matter how I manage my code or my deployments, Beanstalk can adapt.
Exactly. It's all about making your life easier as a developer.
I appreciate that. All right, so we've talked about some of the great things about Beanstalk, but every service has its limitations, right? So what are some of the things that Beanstalk doesn't handle so well? Or situations where it might not be the best fit?
That's a good question. One thing to keep in mind is that Beanstalk does offer less granular control over the underlying infrastructure compared to managing everything manually with EC2.
So if I'm a real control freak when it comes to my servers, Beanstalk might not be the best option.
Yeah, if you need to tweak every little setting and have complete control over every aspect of your environment, then you might be better off going the manual route.
Got it. So it's a trade-off between convenience and control. Makes sense. And are there any other limitations to keep in mind?
Well, while Beanstalk integrates with a ton of AWS services, there might be some niche services or really specific configurations that aren't directly supported. So you might need to get a little creative in those cases.
Okay, so it's always good to do your research and make sure Beanstalk will meet your specific needs before you jump in head first.
Absolutely.
Yeah.
But for a wide range of applications, it's a fantastic solution.
Great. Well, I think this is a great place to take a break. And when we come back, we'll dive into some exam-style questions about Beanstalk. So get ready to test your knowledge.
Looking forward to it. All right, so you ready for some exam-style questions?
Just bring it on. Let's see what we remember.
Okay, so picture this. You've deployed your awesome new web application to Beanstalk. Everything's running smoothly, but you want to make sure you're alerted if your application's CPU usage goes above, say, 80%. Which AWS service would you use to set up this kind of monitoring and alerting?
That sounds like a job for CloudWatch.
Yeah.
I can create alarms and stuff.
You got it. CloudWatch is your best friend for monitoring pretty much everything in AWS. You can track all sorts of metrics like CPU utilization, memory usage, network traffic, and a whole lot more.
And then I can set up alarms to notify me if any of those metrics cross a certain threshold.
Exactly. So in this
Yeah.
case, you'd create a CloudWatch alarm that triggers when your application's CPU usage goes above 80%.
And that alarm can send me like an email or an SMS message so I could jump in and fix things before they get out of hand.
Exactly. It's all about being proactive and staying ahead of any potential problems.
Okay, cool. So CloudWatch is definitely the answer here. But what about some of those other AWS services that deal with monitoring and management, like CloudTrail or Config or Trusted Advisor? Would any of those work in this scenario?
Not really. They all serve different purposes. CloudTrail is great for auditing API calls. Config helps you track configuration changes over time. And Trusted Advisor gives you recommendations for security and cost optimization.
Yeah.
But none of them offer the kind of real-time application monitoring that you need in this case.
Got it. So it's important to know the difference between those services and when to use each one.
Absolutely. And that's what the exam is all about, testing your understanding of how all these different pieces fit together.
Okay, so we've covered monitoring and alerting. Let's move on to another fun topic, troubleshooting. Nobody likes dealing with problems, but it's part of life in the cloud. So what are some common Beanstalk troubleshooting scenarios that our listeners might encounter?
Well, one of the most common ones is deployment failures. Your deployment might fail for a variety of reasons, like maybe there's an error in your code or your configuration settings are incorrect or there's some kind of issue with the underlying AWS services.
So what's the first thing I should do if my deployment goes sideways?
Check the Beanstalk logs. They're like a treasure trove of information. They'll give you details about what happened during the deployment process and any errors that might have occurred.
Okay, so the logs are my first clue. But what if I'm looking at the logs and I see some cryptic error message that I don't understand? Where do I go from there?
Well, remember how we talked about CloudWatch being your best friend for monitoring? It can also be super helpful for troubleshooting. You can check the CloudWatch logs for both your application and the underlying EC2 instances that Beanstalk is using.
So I might get a different perspective on the issue by looking at those logs.
Exactly. And if you're still stuck, Beanstalk has a feature called Enhanced Health Reporting, which gathers even more detailed information about your environment. This can be really useful for those really tricky problems.
So it's like calling in the experts when I can't figure things out on my own.
Pretty much, yeah. Now, what about performance issues? Let's say my application is deployed and it's running, but it's slow or it's not responding properly. How do I troubleshoot that kind of problem?
Yeah, those performance issues can be a real pain. What tools does Beanstalk give me to help with that?
Well, once again, CloudWatch is your go-to tool. It can track all sorts of performance metrics like CPU utilization, memory usage request, latency, and a lot more.
So I can see if my app is running out of resources or if there are any bottlenecks that are slowing things down.
Exactly. And once you identify the problem, you can start to troubleshoot it. Maybe you need to optimize your payload or tweak your Beanstalk configuration or scale up your resources.
Okay, so monitoring is key for both identifying and resolving performance problems.
Absolutely. And now for a quick knowledge check. What are some of the most important metrics that you should be monitoring for application performance?
Well, off the top of my head, I'd say CPU utilization, memory usage request, latency, and error rates. Those seem like pretty good indicators of how my app is doing.
You got them all. Those are definitely key metrics to keep an eye on. And CloudWatch makes it easy to track them all in one place.
Perfect. Now let's move on to another important topic, EC2 instance types. Choosing the right instance type for your Beanstalk environment can make a big difference in terms of performance and cost. So what are the main categories of instance types that our listeners should be familiar with?
Well, you've got your general purpose instances, which are good all-rounders for a variety of workloads.
Okay, those are like the jack of all trades.
Yeah. Exactly. Then you have compute-optimized instances, which are designed for CPU-intensive tasks.
So if I'm doing a lot of number crunching or running complex simulations, I'd want a compute-optimized instance.
Yep. And then you have memory-optimized instances, which are great for workloads that need to work with large data sets in memory.
Like databases or caching servers.
Exactly. And lastly, you have storage-optimized instances, which are designed for workloads that require high sequential read and write performance to storage.
Got it. So it's all about choosing the instance type that best matches the needs of my application.
Absolutely. Now let's put that knowledge to the test with another exam-style question. Imagine you're deploying a database application to Beanstalk, and this database needs high random I/O performance and low latency data access. Which category of EC2 instance type would you choose for this Beanstalk environment?
Hmm. Let's think about this. We need fast access to data, so that sounds like memory-optimized instances would be the best fit.
You nailed it. They're specifically designed for that kind of workload. General-purpose instances wouldn't provide the same level of performance. Compute-optimized instances prioritize CPU over memory, and storage-optimized instances are more for sequential I/O, not random I/O.
Okay, that makes sense. So I'm starting to see how these instance types can really impact the performance of my applications.
Absolutely. Now, let's shift gears and talk about security, which is always a top priority in the cloud. So how do we go about securing our Beanstalk applications and data?
Yeah, security is super important.
Yeah.
What are some of the key things we need to be thinking about?
Well, Beanstalk has a multi-layered security model, just like a good security system should have. You have security groups, which act like a virtual firewall controlling traffic to and from your instances.
Okay, so I can use security groups to restrict access to my application and only allow traffic from authorized sources.
Exactly. And then you have IAM roles, which define the permissions that your Beanstalk environment has to access other AWS services.
So it's all about least privilege, giving my application only the permissions it needs and nothing more.
Precisely. And you can also leverage other AWS security services like KMS for encryption and CloudTrail for auditing.
Okay, so KMS can help me encrypt sensitive data at rest, and CloudTrail can provide an audit trail of all the activity in my Beanstalk environment.
Yep. It's all about having a layered approach to security and using the right tools for the job.
Okay, let's make this practical. Let's say I want to make sure that only authorized users can access my web application that's deployed on Beanstalk. What specific security measures would I put in place?
First off, you definitely want to use security groups to control inbound traffic. You could set them up to allow traffic only from specific IP addresses or ranges.
So it's like having a guest list for my application.
Yeah.
Only those on the list are allowed in.
Exactly. And then you'd use IAM roles to give your application the necessary permissions to access other AWS services. But nothing more. It's all about granting the least privilege necessary.
Got it. And would KMS and CloudTrail play a role in this scenario?
Absolutely. You could use KMS to encrypt any sensitive data that your application stores, like database passwords or API keys. And CloudTrail would give you an audit trail of all the API calls made to your Beanstalk environment, so you'd have a record of who did what and when.
Okay, that makes sense. So it's all about having a layered approach to security and using the right tools to protect my application and my data.
Exactly. Now let's see if you can apply that knowledge to a multiple choice question. You're deploying a sensitive application on Beanstalk, and you need to make sure that all the data stored by this application is encrypted at rest. Which AWS service would you use to achieve this? Your options are AWS Certificate Manager, AWS Key Management Service, AWS Cloud HSM, or AWS Secrets Manager.
Okay, so we're talking about encryption at rest.
Yeah.
That sounds like a job for KMS, right?
You got it. KMS, or Key Management Service, is the service you'd use to encrypt data at rest. Certificate Manager is for managing SSL/TLS certificates. Cloud HSM is for hardware security modules, and Secrets Manager is for storing and rotating secrets. So KMS is the clear winner here.
Makes sense. So it's important to know not just what each service does, but also when to use it.
Exactly. Now let's talk about compliance. Many organizations need to comply with specific regulations like PCI, DSS, IPA, or SOC 2. How does Beanstalk fit into that picture?
Yeah, compliance can be a real headache. So how can Beanstalk help me meet those requirements?
Well, Beanstalk is designed to help you comply with common compliance frameworks. It provides a number of security features and best practices that can help you meet the requirements of those frameworks.
Okay, let's take PCI DSS as an example. What are some things I need to consider if I need to deploy a PCI DSS compliant application on Beanstalk?
PCI DSS is all about protecting cardholder data, so you'd need to make sure your Beanstalk environment meets all the requirements, like encrypting sensitive data, using strong access controls, and regularly monitoring for vulnerabilities.
And Beanstalk's built-in security features can help me with all of that.
Exactly. You can use security groups, IMM roles, KMS encryption, and other features to build a PCI DSS compliant environment.
Got it. So Beanstalk isn't just about easy deployments. It's also about building a secure foundation for my applications.
Exactly. Now let's test that knowledge with another multiple choice question. You're deploying a payment processing application on Beanstalk, and it needs to meet PCI DSS requirements. Which of the following configurations would help you achieve that? Enabling detailed monitoring, configuring auto-scaling, using a custom domain name, or encrypting data at rest?
Well, PCI DSS is all about data security. So encrypting data at rest seems like the most important thing, right?
You're absolutely right. Encrypting data at rest is a core requirement of PCI DSS, and Beanstalk makes it easy to do that using KMS.
Okay, so the answer is D. Now let's talk about blue-green deployments.
Yeah.
This is a deployment strategy that's really helpful for minimizing downtime. Can you explain how it works?
Sure. So in a blue-green deployment, you have two identical environments running side by side. You have the blue environment, which is your live production environment, and then you have the green environment, which is your staging environment.
Okay, so I deploy my updates to the green environment first.
Exactly. You test everything out in the green environment to make sure it's all working properly. And then when you're ready, you switch traffic over from the blue environment to the green environment.
It's like a seamless swap with minimal downtime for my users.
Precisely. And it also makes rollbacks super easy because you can just switch traffic back to the blue environment if something goes wrong.
That's awesome. So blue-green deployments are a great way to reduce risk and ensure a smooth transition when deploying updates.
Absolutely. Now, let's see if you can apply that knowledge to a multiple choice question. You're tasked with deploying an update to a web application running on Beanstalk, and you want to minimize downtime during this process. Which deployment strategy would you choose? Your options are rolling deployment, canary deployment, blue-green deployment, or in-place deployment.
Okay, so we're trying to minimize downtime. And we just talked about how blue-green deployments are great for that. So the answer must be C, right?
You got it. Blue-green deployments are the way to go in this scenario. Rolling deployments and canary deployments can also help reduce downtime, but they don't guarantee zero downtime. And in-place deployments are the riskiest option because they update the live environment directly.
Okay, that makes sense. Now let's zoom out a bit and talk about the big picture. Imagine you're designing and deploying a highly scalable and fault-tolerant web application. This application needs to handle traffic from millions of users worldwide, and it needs to be deployed in multiple AWS regions. What key AWS services and features would you consider when architecting the solution?
All right, so we're talking about building a global application. That's a pretty challenging task. Where would you even begin?
Well, first off, I definitely want to use Elastic Beanstalk to handle the deployments and scaling for my application.
Good choice. Beanstalk would make it much easier to manage the application across multiple regions.
And I'd need some kind of global load balancer to distribute traffic across those different regions.
Absolutely. Something like Route 53 would be perfect for that.
And then I'd need to think about data redundancy and high availability. So maybe a multi-region database strategy using something like Amazon Aurora.
Excellent thinking. And don't forget about content delivery networks like CloudFront to cache static content closer to your users.
Right, that would help improve performance and reduce latency for users all over the world.
And of course, security and monitoring are crucial. You'd want to use all the tools we talked about earlier, like security groups, IAM roles, KMS encryption, and CloudWatch.
Wow, that's a lot to think about. But it's starting to make sense how all these different pieces fit together.
It's all about taking a layered approach and using the right tools for each layer.
Okay, so we've got our global application deployed and it's handling millions of users. Now let's talk about cost optimization. How can we keep those cloud costs in check while still maintaining performance and reliability?
Cost optimization is a huge topic, but here are a few key strategies to keep in mind.
Okay, hit me with them.
First off, make sure you're choosing the right instance types. Don't over-provision if you don't need to. Beanstalk's auto-scaling can help you right-size your environment based on actual usage patterns.
Got it. So I don't need to pay for more resources than I'm actually using.
Exactly. And then consider using reserved instances. If you know you'll need a certain number of instances for a long period of time, you can reserve them upfront and save a lot of money.
Okay, reserved instances are good for long-term commitments. What about for short-term workloads?
For those, you can use spot instances. There's spare EC2 capacity offered at a significant discount.
Ah, so spot instances are a good way to save money on workloads that can tolerate some interruptions.
Exactly. And lastly, use a cost management tool like AWS Cost Explorer to track your spending and identify areas where you can optimize.
Okay, so it's all about choosing the right resources, using them efficiently, and monitoring your costs closely.
Exactly. Now, let's put that knowledge to the test with a scenario. You're responsible for a Beanstalk environment that runs a batch processing job every night. This job requires a lot of compute power, but it only runs for a few hours. What cost optimization strategy would you implement in this case?
So we have a compute-intensive job that runs for a short period of time. That sounds like a perfect use case for spot instances, right?
You got it. Spot instances are the most cost-effective option in this scenario. You're only using them for a few hours each night, so you don't have to worry too much about them being interrupted.
Okay, that makes sense. Now let's talk about environment variables. They're a way to configure our Beanstalk applications without modifying the code itself. How do those work?
Environment variables are basically key value pairs that you can use to store configuration settings for your application.
So instead of hard-coding things like database connection strings or API keys into my code, I can store them as environment variables.
Exactly. That makes your application more portable and easier to manage because you can change those settings without having to modify the code.
Got it. So I can set different environment variables for different environments, like development, testing, and production.
Precisely. And you can manage those environment variables in the Beanstalk console or through configuration files.
Okay, so environment variables give me a flexible way to configure my application. Now let's talk about serverless architectures. They're becoming increasingly popular. So how does Beanstalk relate to this trend?
Well, Beanstalk itself isn't strictly serverless, but it can be a good stepping stone towards a more serverless architecture.
Okay, how so?
Beanstalk helps you abstract away some of the infrastructure management tasks that you'd normally have to deal with, so it can make it easier to transition to a serverless approach down the road.
Got it. So Beanstalk can help me get comfortable with some of the concepts of serverless computing.
Exactly. Now, here's a question that ties this back to Beanstalk. You're developing an application with a web front end and a back end API. This back end API only needs to run when responding to user requests. What AWS service would be a good fit for the back end API in this scenario?
So we have an API that only needs to run on demand. That sounds like a job for Lambda, right?
You nailed it. Lambda is a serverless compute service that lets you run code without provisioning or managing servers. It's perfect for event-driven workloads like APIs.
Okay, so I can trigger my Lambda function whenever a user makes a request to my API.
Exactly, and you only pay for the compute time that your function actually uses.
That's awesome. So Lambda is a really powerful tool for building serverless applications.
Absolutely. Now let's talk about configuration files. They're another way to manage the settings for our Beanstalk environments. What are the advantages of using configuration files?
Well, I imagine they make it easier to manage complex configurations and keep everything organized.
Exactly. With configuration files, you can define a whole range of settings for your environment, including things like software packages, environment variables, network configurations, and security options.
So instead of having to manually configure all those settings in the Beanstalk console, I can just define them in a file.
Precisely. And that makes your deployments more repeatable and less prone to errors.
Okay, that makes sense. Now let's test your knowledge on this. You're deploying a web application to Beanstalk, and you need to configure the environment to use a specific version of PHP. You also want to set some custom environment variables. How would you do this? Your options are manually configure the settings in the Beanstalk console, use a configuration file, use environment variables only, or hard-code the settings into the application code. Okay, so we want to configure the PHP version and set some environment variables. Hard-coding those settings is definitely a bad idea, and using environment variables alone might not be enough to cover all the configuration needs. So that leaves us with manually configuring in the console or using a configuration file. Which one is the better approach?
Using a configuration file is definitely the way to go. It lets you define all those settings in code, which makes them more repeatable and easier to manage.
Okay, so configuration files are our friends. Now let's talk about logs. They're an essential part of troubleshooting and monitoring our Beanstalk environments. So what types of logs are available to us?
Beanstalk provides a variety of logs that give you different insights into your application and environment.
Okay, like what?
You have application logs, which are generated by your application code itself.
So those logs can help me track what's happening inside my application and debug any errors.
Exactly. Then you have web server logs, which are generated by the web server running your application.
Those logs would show me things like incoming requests, outgoing responses, and any errors that occurred at the web server level.
Exactly. And then you have system logs, which are generated by the operating system running on your EC2 instances.
Those logs would give me information about system-level events, resource utilization, and any errors that occurred at the operating system level.
Precisely. And lastly, you have CloudTrail logs, which track all the API calls made to AWS, including those made by your Beanstalk environment.
So CloudTrail logs are really useful for security auditing and compliance.
Exactly. Now let's wrap up this section with a scenario. You're troubleshooting a web application on Beanstalk, and you suspect that the issue is related to a recent code change. Where would you look for logs to help you pinpoint the root cause of the problem?
So we're looking for logs that might reveal clues about a code change. That sounds like application logs would be the best place to start, right?
You got it. Application logs are the most likely place to find information about errors or unexpected behavior that might be caused by your code.
Okay, that makes sense. Now let's move on to one of my favorite topics, automation. Automating our Beanstalk workflows can save us a lot of time and effort. So what are some ways that we can automate things?
Automation is your best friend in the cloud. And Beanstalk offers a number of ways to automate your workflows.
Like what?
Well, you can use the AWS CLI or SDKs to interact with the Beanstalk API.
So I can write scripts to automate tasks like creating environments, deploying applications, or updating configurations.
Exactly. And for those who love infrastructure as code, you can use tools like CloudFormation to define your Beanstalk environments and applications as code.
Ah, so I can manage my entire infrastructure in a repeatable and version-controlled way.
Precisely. And for automated deployments, you can use services like AWS Code Pipeline.
So I can set up a pipeline that automatically builds tests and deploys my application whenever I push code changes to my repository.
Exactly. Now let's test your knowledge. You're deploying a web application to Beanstalk, and you want to automate the process of building, testing, and deploying the application every time code changes are pushed to a Git repository. What AWS service would you use for this?
Okay, so we need to build a pipeline that handles the entire deployment process.
Yeah.
That sounds like a job for Code Pipeline, right?
You got it. Code Pipeline is specifically designed for building automated deployment pipelines. The other options like CloudFormation OpsWorks or Code Deploy are all great tools, but they're not the best fit for this specific scenario.
Okay, I'm getting the hang of this. Now let's talk about monitoring. What are some key things that we should be monitoring in our Beanstalk environments?
Monitoring is essential for making sure your applications are healthy and performing well. There are three main areas to focus on: application performance, environment, health, and security events.
Okay, let's break those down. Starting with application performance, what should we be watching?
For application performance, you want to track metrics like request, latency, error rates, CPU utilization, memory usage, and so on. These metrics will give you a good indication of how your application is performing under real-world conditions.
So request latency tells me how quickly my application is responding to requests. Error rates show me how often things are going wrong, and CPU and memory utilization tell me how much of my resources are being used.
Exactly. Now, what about environment health? What are some things to monitor there?
Well, we definitely want to make sure that our EC2 instances are running and healthy, and that our load balancer is working properly, distributing traffic across those instances. And since Beanstalk environments are deployed in specific availability zones, we need to make sure those availability zones are healthy too.
You got it. It's all about having a holistic view of your environment and making sure all the pieces are working together harmoniously. Now, what about security? What are some red flags we should be watching for?
Well, failed login attempts are always a bad sign. A sudden increase in those could indicate that someone is trying to brute force their way into our system. And suspicious API calls that deviate from the normal patterns of our application could also signal malicious activity. And of course, we need to track any unauthorized configuration changes that could compromise security.
Those are all excellent points. Now, what tools and techniques can we use to effectively monitor all these different areas?
Well, CloudWatch seems like the obvious choice, right? It can track all sorts of metrics, and it integrates seamlessly with Beanstalk.
You're absolutely right. CloudWatch is your one-stop shop for monitoring everything in your Beanstalk environment. You can use it to track metrics, set alarms, create dashboards, visualize data, and a whole lot more.
So CloudWatch is like our central command center for monitoring everything that's going on.
Exactly. And here are a few specific ways you can use it. You can create metric alarms that will notify you if certain thresholds are exceeded, like that 80% CPU utilization we talked about earlier. You can build custom dashboards to visualize those key metrics and get a comprehensive overview of your environment's health and performance. And you can use CloudWatch logs to centralize all the logs from your Beanstalk environment, which makes them much easier to search, analyze, and use for troubleshooting.
It's a lot of monitoring power at our fingertips. Now let's talk about logging. What types of logs are available to us in Beanstalk?
Beanstalk provides access to a variety of logs, each offering a different perspective on your application and environment.
Okay, like what?
You have application logs, which are generated by your application code, giving you insights into its internal workings. Then there are web server logs produced by the web server running your application, containing information about incoming requests and responses. And of course, you have system logs generated by the operating system running on your EC2 instances, providing details about system-level events.
So we have logs for our application, the web server, and the operating system. What else?
And lastly, we have CloudTrail logs, which track all API calls made to AWS, including those made by your Beanstalk environment. They're essential for security, auditing compliance, and troubleshooting issues related to AWS service interactions.
Wow, that's a comprehensive set of logs, each one providing a different piece of the puzzle. Now let's wrap up this discussion on monitoring and logging with a scenario. Imagine you're experiencing performance issues with your Beanstalk application. Where would you look for logs and metrics that could help you diagnose the problem?
That's a great question. So if you're facing performance issues, you'd start by checking CloudWatch metrics. Look at things like CPU utilization, memory usage request, latency, and error rates. These can help you pinpoint potential bottlenecks or issues.
Okay, so those metrics can give me a high-level view of what's going on.
Exactly. Then you'd want to dive into the application logs. Look for any error messages, long-running operations, or unusual patterns. These logs can provide valuable insights into how your application is behaving.
So I can see what's happening inside my application and try to track down the source of the problem.
Exactly. And if the issue seems related to a specific EC2 instance, you could also investigate the system logs for that instance, looking for signs of resource contention or other problems.
Okay, so we've got CloudWatch metrics, application logs, and system logs to help us troubleshoot performance issues. What about web server logs? When would we look at those?
Web server logs are useful for understanding how clients are interacting with your application. They can reveal things like errors, slow response times, or unusual traffic patterns.
So if I'm seeing a lot of errors or slowdowns, I might check the web server logs to see if there's anything unusual happening on that side?
Exactly. It's all about using the available tools and information to get a clear picture of what's going on, and then using that knowledge to troubleshoot the problem.
Okay, I think that's a great overview of monitoring and logging. Now let's move on to deployments.
All right, so let's talk deployments. They're kind of a big deal, right?
Yeah, for sure.
Yeah.
Getting our code out there safely and efficiently. That's the whole point.
Exactly. So when we're talking about Beanstalk deployments, it's kind of like picking the right tool for the job. You've got different options.
Right. Like we touched on this before, get S3 ZIP files.
Mhm.
What are the pros and cons here?
Well, if you're working on a project with lots of updates, constantly pushing changes, Git integration is usually your best friend.
Because it's just automatic.
Beanstalk pulls the latest code whenever I push.
Exactly. Super streamlined. And then there's S3, maybe for larger applications, pre-built packages.
Or if I'm not using Git for whatever reason. Right. Then ZIP files direct upload. It's simple, but maybe not as elegant for ongoing development.
Got it. So choose your deployment weapon wisely. Now, I know Beanstalk also has these different deployment policies. What are those all about?
Ah, yes. The deployment policies. This is how we control the rollout of our updates. Like, are we smashing the gas pedal or taking it slow and steady?
Okay, I like that analogy. So what are our options?
You've got all at once, which is like flooring it. Every instance gets the update immediately.
Sounds risky. If something's wrong, everything breaks.
Exactly. High risk, high reward.
Yeah.
Then there's rolling updates, much more cautious.
Like dipping your toes in the pool before jumping all the way in.
Precisely. It updates instances in batches. So if there's a problem, only a portion of your users are affected.
Okay, much less scary.
Mm.
And what is that other one? Immutable.
Ah, yes. This is the clean slate approach. It spins up a whole new set of instances with the update.
And then just swaps them out with the old ones.
Exactly.
Yeah.
No messing around with the existing instances. Rollbacks are super easy, too. Just switch back to the old set.
Okay. I'm liking that a lot. So this sounds like another exam question waiting to happen.
Right.
Yeah.
You know it. All right, picture this. You're pushing a critical update to your production app on Beanstalk. Downtime is your worst nightmare. Which deployment policy are you going with?
Okay, minimizing downtime. That's got to be rolling updates, right? Slow and steady wins the race.
Spot on. All at once is too risky. Immutable is great, but maybe overkill for a simple update?
Awesome. Now let's talk about versions and aliases. What are those all about?
Versions are like snapshots of your application at different points in time. Every time you deploy Beanstalk creates a new version.
So it's like a history of all my deployments.
Exactly. And aliases, these are like friendly names that you can give to specific versions.
Okay, so let's say I've got a bunch of versions out there, but I want to point my users to the latest stable release. How would aliases help me with that?
You'd create an alias, maybe something like prod for production, and you'd point that alias to the specific version that represents your stable release.
And then my load balancer would use that alias to direct traffic.
Yeah, exactly. So users always hit the right version, and rollbacks are super easy. Just point the alias to a different version.
Okay, that's really clever. So versions are like checkpoints and aliases are like signposts pointing to those checkpoints.
I like that analogy. All right, one last challenge for you. You've got an app on Beanstalk, multiple versions deployed. You need to send production traffic to the latest stable release, but keep those older versions around just in case. How would you set this all up?
Okay, let me think. So first I need to figure out which version is my stable release. Then I create an alias like prod and point it to that version. Then I configure my load balancer to use that prod alias, and I make sure I don't delete those old versions.
Perfect, you nailed it. It's all about combining versions, aliases, and load balancer configurations to create a stable and flexible deployment workflow.
Awesome. Well, I think we've covered a ton of ground today. Beanstalk deployments, scaling, security, troubleshooting, monitoring.
We really went deep.
If our listeners take away just one thing from this whole deep dive, what would it be?
I'd say this Beanstalk is a powerful tool. But like any tool you need to understand how to use it effectively, when you do that, it can make your life as a cloud engineer so much easier.
Absolutely. It takes care of a lot of the heavy lifting so you can focus on building great applications.
Exactly.
Yeah.
And that's what it's all about. So keep learning, keep experimenting, and keep building amazing things in the cloud.
Couldn't have said it better myself.
Yeah,
Thanks for joining me on this deep dive into Beanstalk.
my pleasure. Until next time, happy cloud computing, everyone.
Oh, yeah.